Hello students, today we are going to work on questions that are likely to be asked in board examination as a whole. And if you see, I have taken one of the question from the prelim paper that I have received from some of the students as a doubt. So I'm going to work on that question number 2, and 3 questions are there which carries 4 marks each. So let us start with the first question. It says Jitesh deposits a certain sum of money. So we don't know the P here. So this represents P, certain sum of money every month in a recurring deposit for an account for a period of 24 months. This is our N. If the bank pays the rate of interest, that is 11%, this is our R, and the Jitesh gets 53,500 as a maturity. This is our mature value, and we have to find out the sum of money deposited every month by Jitesh, that is P. We have to find out. So P is question mark. So let us do the sum first of all. So I'm going to start from here. So answer. So let us make a proper way of doing this sum. So answer question number 2. So that will be our 2, and it is first one. So how much amount he is depositing we don't know. So P is equal to X. R is given as 11%. N is given as 24 months. That means 2 years. And mature value we have obtained, that is he is obtaining after 2 years, that is 53,500 rupees. And interest formula is given like this: P n bracket n plus 1 upon 2 multiply by R upon 100 multiply by 1 upon 12. Maturity value formula is Pn plus I. So what are we going to do? We are going to put the mature, we are going to use this formula straight away because I we can replace it here. So therefore mature value is how much? 53,500 is equal to Pn. P is given as X into 24 plus I. What is the value of I here? So formula we are going to replace. So P is given as X multiply by 24 multiply by 24 plus 1, 25 upon 2 multiply by R upon 100. R is given as 11% upon 100. 11%, that is 11 upon 100, and 1 by 12. First of all we are going to calculate this portion. So it becomes easy. So we will calculate this portion. So let us start. 12 2s are 24 and 24 cancel. 25 1s are and 25 4s are. So what is the remaining we are getting after cancellation? That is 53,500 is equal to 24x plus 11x upon 4. Take the LCM, so it becomes 53,500 is equal to 96x plus 11x upon 4. 4 goes this side. So therefore 53500 multiply by 4 upon 96 plus 11 107 is equal to x. Therefore x is equal to, if you cancel this one, what you are going to get? 107 5s are 5 7s are 35 and 5 10s are, so it is 107 5s are and 2 0. So 500 multiplied by 4, that is going to fetch 2000 rupees. So the amount that he is depositing, that means principal amount P that is depositing every month for 2 years, is 2000 rupees. I hope you understood this sum, and it's pretty simple and easy. Just we have to put the values and calculate. So this is the answer of question number 2-1 about banking. Any doubts, any questions, please let me know. Okay, let us move on to the next one, that is number 2. So let me copy this part so it becomes easy, because I have to take the another screen for that one. So we are going to take this one and we move it to the next part. So here, okay, so this is the second sum. So let us work it out the second sum. What it says, if the quantities A, B, C and D are in continued proportion, prove that. So we have to prove. First of all, it should be in a continued proportion. So our answer begins like this. Answer, right? Question number 2 second. So 2.2. And our answer begins in this manner. So first of all, we'll write about the continuous proportion. So A upon B is equal to B upon C is equal to C upon D. This is the meaning of continued proportion. So A, B, C, D are in continued proportion. So if you want to start, you can start like this. A, comma B, comma C, comma D are in continued proportion. Okay, and this will be equal to what? K. So now A upon B is equal to K, B upon C is equal to K, and C upon D is equal to K. Now C is equal to dk, and here B is equal to ck, where you replace the value of C by dk. So dk dot k. So what you got? B is equal to dk square. In the same manner, here A is equal to bk, where you replace the value of B as dk square dot k, and you get the value of A as dk cube. Make a box so that you understand the values that you have obtained after replacing the other values, and here you get A, B and C. So finally your answer will be going to obtain in D, because A is replaced by dk cube, B is replaced by dk square, and C is replaced by dk. Now let us begin here. So here A minus B whole cube upon B minus C whole cube is equal to A upon B. That is the thing that we require to prove. So replace the value of, what is the value of A here? The value of A is dk cube. And what is the value of B here? dk square. This is going to be whole cube upon, what is the value of B here? dk square, minus, what is the value of C here? dk whole cube. In the same manner, what is the value of A? dk cube upon, what is the value of D? Nothing. So we put D as D. Understood? Why? Well, value of D is not found further, because it is saying that A, B, C, D are in continued proportion. It is not A, B, C, D, E. If it would be E, then we would have got D, the value of D as EK. But here we are given as A, B, C, D. So D is the final one. Okay. Now, before we go for, here comes therefore and here comes therefore, before we go for the further calculations or simplification, find out what we can get rid of. So here if you see, here we get D and K common. So what is common here? So make a big bracket, and the common is D is common and K square is common. Bracket, what is going to remain inside? K is going to remain inside, and minus 1 is going to remain inside, and here it is going to S cube upon, here what is common here? dk is common. So what you are going to have? K minus 1 and whole cube is equal to, here dk cube upon D. Now if you see here, this cube is going to relate to this part as well as this part. Same here. So here d cube and k raised to 6 bracket k minus 1 whole cube upon, here d cube k cube bracket k minus 1 whole cube is equal to dk cube upon D. I hope you understood. Here therefore d cube cancel, this part and this part cancel. From here D and D cancel, here 3 and here it becomes 3. So what is remaining here? K cube is equal to K cube. So LHS equal to RHS, hence proved. I hope you understood the way we are doing the sum. Any questions, any doubts, please let me know. I will sort out. Okay, let us go to the next one. Next question is related to prove that. So let me take this copy of it and we'll put it to the next one. I didn't copy. Okay, here. So we are going to work out the next third question of question 2. Okay. So here answer 2.3. So this is our margin. Okay, and we'll write down the question. Cos theta upon 1 minus tan theta minus 1 minus cos square theta upon cos theta minus sin theta. And what do we require here? Cos theta plus sin theta. So let us start with LHS. So first of all LHS. So LHS is what? Cos theta 1 minus tan theta minus 1 minus cos square theta upon cos theta minus sin theta. Okay, let us first of all simplify. Always go from complex to simple. So here implies, or you can say therefore. So here cos theta upon 1 minus sin theta upon cos theta minus 1 minus cos square theta upon cos theta minus sin theta. I don't have space, so I am going in this manner. Okay. So here, now first of all take LCM. Cos theta upon, here LCM is this one. So here cos theta minus sin theta upon cos theta minus 1 minus cos square theta upon cos theta minus sin theta. So I hope you understood this one. And then cos theta goes up. So it becomes implies cos square theta upon cos theta minus sin theta minus 1 minus cos square theta upon cos theta minus sin theta. If you see that LCM is same, so here it becomes cos theta minus sin theta, and here it becomes cos square theta minus 1 minus minus becomes plus cos square theta. Here cos square theta, or we can go straight away. Okay, anyway, so if we say cos square theta 2 cos square theta minus 1 upon cos theta minus sin theta. Now if we take over here as cos square theta as 1 minus sin square theta, then 2 bracket 1 minus sin square theta minus 1 upon cos theta minus sin theta implies 2 minus 2 sin square theta minus 1 upon cos theta minus sin theta. I think this is going to be a little bit longer. So what I am going to do, I am going to consider this part. I am going to consider this part as this one I am talking about. This one. We can go further, not a problem, not an issue. We can go further, but it will be too lengthy. But here I can change it. So if I continue from here instead of this one, if I continue from here, so it becomes cos square theta minus sin square theta upon cos theta minus sin theta, and using the formula a square minus b square, so we get cos theta plus sin theta, and we get cos theta minus sin theta upon cos theta minus sin theta. So this one is cancelled, this one and this one cancel. So what is remaining here? Cos theta plus sin theta, which is equivalent to RHS. Hence LHS equal to RHS. I hope you understood. So instead of doing this step, you can go directly from here. So otherwise it will be too lengthy. Again we'll get 1 minus 2 sin square theta, and then splitting again, and then bringing back to cos square theta. So instead of going for this one, we are cutting it short to this part. Understood? So cos square theta minus 1 minus cos square theta is what? Sin square theta. So cos square theta minus sin square theta upon cos theta minus sin square theta. And this is actually nothing but, if you remember the formula, a square minus b square. What is a square minus b square? A plus b and a minus b. So here we get a minus b, and here underneath, or you can say denominator, is a minus b. A minus b cancel. So this part and this part is cancelled. So what you get? Cos theta plus sin theta. So cos theta plus sin theta is what? That is the actual thing that we require. So that is RHS. Hence proved. So therefore LHS equal to RHS. I hope you understood these 3 questions. If you have any doubt or any sort of ambiguity, please let me know. Okay. Thank you guys. Thank you very much. We'll solve the next question 3 in the next episode.